Here we're being asked to multiply two rational expressions. Since they're both already fractions, what I want to do first is to look at the top and the bottom of each of the fractions, the numerator and the denominator, and see if I can factor it at all. The first thing you look at when you're factoring is to see if there's a greatest common factor, if there's anything that you can divide each of the terms by. So if I look at the first fraction, the top doesn't look like there's a greatest common factor, but the bottom, the denominator, I notice the 15 and the 20, I know I can divide them both by 5, and each of the terms has an x. So the greatest common factor is 5x. So if I pull out the 5x from the 5x squared and the 20x, if I divide them both by 5x, what's left? Well, 5x squared divided by 5x, I'm going to have a 3 and also another x. So that's 3x. And 20x divided by 5x, I'm just going to have a 4. So it would be 3x plus 4. And if you want to multiply that and make sure that you come up with 5x squared plus 20x, you can. Like 5x times 3x is 15x squared, and 5x times 4 is 20x. Now let's look at the second fraction. The 5x I can't do anything with, but the bottom, the denominator, it looks like I might be able to factor this. Now this is a little bit more extensive. I need to see if I can factor it using the grouping method, so I'm going to go to another slide. So when we are looking at this, what we're trying to do is break up that middle term, that plus 5x, into two numbers that add to plus or positive 5x. And then we're going to have two groups that we're going to look and see if we can factor each of those groups. So to figure out what those two magic numbers are that add to 5x, there's so many possibilities. There's an infinite number of possibilities. What you do is you multiply the coefficient of the first term with the last term. 2 times -3 is -6. And then you take that middle coefficient, positive 5. So we are looking for two numbers that multiply to give us -6 and add to give us 5. So if we go through all the different options, we see that it is positive 6 and -1. So those are the two magic numbers we're going to separate 5x into. That's the same as positive 6x minus 1x. So we're going to put that there. And now we're going, instead of looking at each of those four terms and thinking what can we factor out of all of them, we're going to group them into two groups. So let's look at the 2x squared plus 6x and see what we can factor out of that, and the -1x minus 3 and see what we can factor out of that. So when we look at this first grouping, I see they have a 2 and a 6, so I know I can divide them both by 2, and they each have at least one x. So the greatest common factor is 2x. And what's left when I divide each of those terms by 2x? Well, 2x squared divided by 2x, I'm going to have 1x left. And 6x divided by 2x, I'm just going to have a 3. So it would be x plus 3. And then the second term, there's not as many things that you can divide both of those by. We can divide them by 1, by -1. We have to divide it by something in this process. So I'm going to divide it by -1 and see what we have. And if I divide each of those terms by -1, I end up with an x and a positive 3. And this is what you want. Notice that what's in the sets of parentheses here is the same. Both has an x plus 3. So now when you look at each of these terms again, we ask, what can we factor out of each of those? What do they have in common? And they both have an x plus 3. So I can factor out an x plus 3, and then what's left? The 2x and the -1. So this is the factored version of the 2x squared plus 5x minus 3. So let's put that back into our problem. Now that we have factored both of our fractions, both of our rational expressions, we want to look at it and see if there's anything that we can cancel out. Rather than multiplying it all together again, we're looking at these smaller broken up chunks, these smaller factors, and seeing if we can cancel anything out first so it's not as messy. So by canceling out, I mean if you have a number in the numerator in the top and also in the denominator, the bottom, then you can cancel them out if it's the same number. Because anything divided by itself is 1. Like 4 or x minus 4 divided by x minus 4 is 1. So in this case, notice that there's a 2x minus 1 in the top and a 2x minus 1 in the bottom. So let's cancel those out. There's also a 5x in the top and a 5x in the bottom. So we can cross those off as well. Because again, anything divided by itself is 1. And there's nothing else that it looks as though I can cancel out. So let's think about what's left. We're going to multiply across what's left now. In the numerator, we don't have anything, so we just put a 1. In the denominator, we have a 3x plus 4 and an x plus 3. We can also multiply this out if we want using the FOIL method, and we get this 3x squared plus 13x plus 12.